Welcome friends to our Gymkhana TV, and again I start with my topic. This is numerical method, in which I start the introduction of the numerical method and interpolation. In our previous session I tried to explain the importance of the numerical method, and I hope you get the importance of the numerical method. I start with the interpolation. So basically the interpolation is what? It's the reading the data between the line. If we tabulate the entire data in the x and y term, because previously I explained we deal with the y is equals to f of x is our main equation, where x is dependent x is independent and y is dependent. So basically I have two variables and I want to tabulate the entire value in the term of x and y. I initialize the first value is x0, another one is x1, or you can get that x1 with the x0 plus h. That means I put some increment into a previous value to get the another value. If I want to get the x2, again I put the 2 increment into x0 to get the x2, and so on. So interpolation is what? Interpolation is to get the value of y, the corresponding value of x is given between the range x0 to xn is known as a interpolation. In simple word, I want to find the value of y where x is given between the range is known as a interpolation. Otherwise it is known as a extrapolation. For the interpolation, our questions or our problem is where some y is missing and some x is missing. For the interpolation, we try to convert our interpolation method into two and more than two, that means three category. The first is with the equal interval. Here I say the equal interval, that means my x value is equally spaced. With the unequal interval, that means my x value is unequally spaced. Central interpolation, this is the another method to get the central value of the interpolation. So here I explain the three different category of the interpolation method. According to this category, we have a number of the method to solve the problems, right? Before we start the interpolation data is depend on the operators, and it is also depend on the finite difference theory. Finite difference theory is what? It's the calculus of the finite difference deal with the changes in the value of dependent variable due to finite changes in independent variable. That means the finite difference is the calculus of this equation, where with some situation if x is changes, corresponding y is also changes. The calculus between these changes is known as a finite difference method. There are 4 or 5 operator which is belong into finite difference method. Is your first operator is identity operator I. By the definition of identity operator, if I apply the I on my function f of x, what I get I of y, or I can write f of x equals to y by this equation. Ultimate I get the f of x or y. That means there is no difference in the function. Second one is shift operator, which is denoted by E. This is shift operator. The formula for the shift operator is E of f of x. I apply the shift operator on this function. What I get f of x plus h. here I get a function with the one increment. Means if I initialize this shift x value with the 0, and this f of x is what? This is y naught from the table, and this one is y naught plus h, right? So shift of e of y naught, this y naught plus h give the y1 value, because you can write this x naught plus h is f of x1, and for f of x1 I can write the y1. So shift on y naught always give the one increment as y1. I can explain, or we can understand with the graph method. If I have the y, here I am taking the y value, and this one is my y naught, this one is y1, and this one is y2, and so on. This is yn. If I apply the shift on y1, by the definition every shift get a single increment, so this y1 jump into a y2. So my cursor which was at y naught, now it is at y1. If I apply the shift on y1, every time I get the one increment, so I get the y2, and so on. I get the yn value, and see here I get the forward increment in the forward direction. That's why this shift operator may know as a forward shift operator. This is for the 1 degree. If I have the e raised to power 2 of y naught, that means what? E raised to power 2 of y naught, that means e raised to power e of y naught. One increment is y1, it's give the y1 value, y naught it's give the y1 value. Then another increment at the y1 position. See, I apply the shift at y0 position, I get y1. Here again I have a shift operator, I apply the shift operator on y1, I get y2. So ultimate, when I apply the e raised to power 2 on y0 position, what I get? I get 2 increment at the position. So this is here e raised to power 2 y0 equals to y2 position. In general, e raised to power n, the degree of e is y0 is give the yn value, and because it's give the forward direction increment, that's why it's known as a forward shift operator. In this shift operator we have the another operator which is known as a inverse shift operator, e raised to power -1. If I apply the e raised to power -1 on f of x, what I get f of x minus h. That means I get a single decrement in my function definition. If I initialize this value with y0, it's come to y0 minus h, but there is no such a value in my table, because my table in the positive direction and I start my table with the y0 position. I don't have the y minus 1 value. So here for every shift inverse value, I will initialize the x1 rather than x0. So e raised to power -1 f of x1 is f of x1 minus h. That means e raised to power y1 give the y0 value, because f of x minus h is y0, x0. This is f of x0, and this f of x0 is known as a y0 by the definition. If I explain this definition with the graph, here again this is our y value, this is y0, here y1, y2 and so on yn. If I apply the e raised to power minus 1 on the y1, what I get y0 by the solution. Similarly, if I apply e raised to power minus 1 at the y2 position, I get y1. So see, here I get a single decrement in a backward direction. That's why e raised to power minus 1 is sometimes known as a backward shift operator. And this is for the e raised to power minus 1. If I apply this is e raised to power minus 2, then y1, it's give the y minus naught value, but we don't have y minus 1 value. So here if I apply e raised to power minus 2 at y2 position, this position, ultimate I get y0 value. So we can say that these are the backward shift operator and this is the forward shift operator along with the identity operator.